What happened?
The whole slide is shown.
Fix it first. Escape.
Good evening, everyone. So today, our group from Cutsawit will present our project. Okay, so we've identified the problem faced by the oil palm entrepreneur, which is they use the current mineral harvesting process, which is inefficient and it delayed the collection. Also, they face a problem to reach the food at different height. Okay, so this is the device benchmarking table. As you can see, there are three user needs. Number one is they need or target user need a tool that can faster their daily production. And number two, the tool must be lightweight, and also number three, the tool must can cater the different tree height problem. So this one is our product, and this tool is the current tools. So this is the digital image of our prototype, of our product. This is a blade and also the piston, which we utilize the hydraulic system, also the lever. So the working system is very simple, which is when we just push the lever and the master piston will push the flute, and the flute they connected to the slave piston will push the piston and push the blade and cut the branch. So this is the design spec table. So to solve the first user need, which is the need tool that can fasten the daily production, we set a target for one fruit bunch to be cut at most 48 seconds. And number two, we set our product to have weight at least, but the weight of the product is less than 5 kilo. And number three, we have applied a telescopic system to our pole, and the system is believed to can be adjusted from 4 to 6 meters, which is can solve the tree height problem. So for number one design analysis, we need to find the slave piston diameter angle and also the blade spec. So after we do the calculation, we found out the surface area to be cut is between 2000 mm square and 4500 mm square. So the blade width is 160 mm, and the diameter of the slave piston is 24.1 mm. So for number two design analysis, after the calculation we do, we find that the material suited for our pole is to use aluminium 6061 E6, and the total mass of the pole is 4.63 kg. And number three, our pole will have at least 5 segments to reach the 7 meters.
Okay, so next is our test card. For test card, we have 3 features. So the first features that we need to test is faster daily production. This feature is connected to the engineering target, which is cutting time 0.8 minutes per fruit bunch. And the second feature to test is lighter tools to decrease strain and fatigue, which is for the engineering target to have no product less than 5 kg. And the last feature to test is reach very big heights. The engineering target for that is to have maximum length code of 6 meters and minimum of 4 meters. So this is the validation video process. This is the first engineering target. And this is the second engineering target. And this is the last engineering target. Okay, so based on that, the validation for the first feature to have faster daily production, the result that we get to cut one branch is 11.3 seconds, which is below than our target, which is 48 seconds, or previously we said 0.8 minutes per fruit branch. So the second validation to have lighter tools to decrease strain and fatigue. Our whole product here weighs less than 1.9 kilograms. Which is less than our target of 5 kilograms. And lastly, the feature to test, which is reach very little heights. So our total length that we measured is 4.52 meters, which is within our range of 4 to 6 meters. So for the first features, actually for the blade itself, we have to scale down because of the market limitation. So we choose the only available blade in the market, which is very small in comparison to our calculation previously. As for other two features, that we follow the calculation.
Okay, in terms of social impact, our tool make work easier and faster. At the same time, reduce hand injury and tiredness. And our tool also safer than cutting leaf manually. From an environmental perspective, the system is designed to be simple and environmentally friendly. Our system use water only and no use of oil, electricity, motor or machine. This leads to low pollution, zero carbon emission, very low noise pollution. Effect on economy, this could save money by reducing labor. Work can be done faster, which efficiency lead to the higher income. Motorized machine also expensive at the beginning. For the safety, regarding the safety consideration, manual operation lead to low risk of engine accidents of motorized machine. Simple water-based system, also easy and safe to use. No complex machine, leads to easy to maintain and use. The main stakeholder are workers or operators which want safe and easy cutting, farmers or owners which prioritize efficient, low cost and operation. Meanwhile, local community seeks minimal noise and environmental impact, while government and regulators body ensure safety and follow basic laws. Challenge and conflicting needs, which cutting must be safe yet efficient. Low cost method must follow safety rules. Protect workers while keeping the process simple, balance efficiency with minimal environmental disturbance. Regulation and guidelines. Worker safety are followed by OSHA 1994, Environmental Quality Act 1974, issued that pollution control. Manual project must follow basic safety rules. Some standards do not clearly cover small manual projects. Extra care needed. Safety measure, manual operation, which lead to low risk of injury. No electricity leads to low shock hazard. No chemicals or oil. Safe for workers and environment. Simple water-based system, easy and safe to use.
Oh, thank you.
Okay. Go to the first slide. I have any question. So, what is the problem here? I mean, inefficient? What do you mean by inefficient?
Innovation for me, for us, it is because of the low productivity of the palm oil itself. Because we know that we said that only 250 until 350 production per day. So innovation, it means that the production is low because of the
My point is here, inefficient is not quantitative. So you have to put there, inefficient, then you explain what is that. Production, what else? Which is the time basically for production done.
basically we can move, take a long time.
The other one, like what the current one usually is fixed length, so you can have the different lengths from whatever short trees to long trees, and then anything else? Like I'm not sure about that one, but anyway, it's okay because that's compared to the, I guess. So this is your 3 user needs, right? Okay. So, what do you design spec now? So, how do you get the 48 seconds?
This is from the article that I found. From what I said, 0.8 minute per day by using the manual harvesting. This is 0.8. They do the experiment at the orchard itself, and then they take the time per day, and then to get 0.8. 0.8 minute, which is 40.
That's what the manual one.
The manual one is.
So you want to achieve the same as the manual. But you put 48 seconds.
At most. So this is
Anyway, if you're going to beat some or whatever, compete with something, you don't go with the same target. But it's okay. So you get that one based on the manual. So you're not really improving the production per se.
I think the manual compared to the like the automatic or the motorized one.
Manual now, 48 seconds.
Okay.
Yours, 48 seconds.
No. If you get below.
No. There is no below. When you do your calculation, you have to start with a number. If you say below, which number you're going to put in your calculation? You're going to put 20, 50, whatever, 5. Cannot just below. That has to be specific to engineering target. Because that's the one you want to achieve. You cannot leave it plain. So my point here, when you put 48 seconds, right? So it's like the same as the current one. So you don't fulfill your first user need to have higher production. That's my point. That's why I asked it, where did you get the 48 seconds? Alright. So that's for me is question mark. Alright. Then after that, I don't know, this 5 kg you get from where?
This also from the article also.
So why do you need the user then?
Sorry?
Why do you need the user? The farmer doesn't matter. I go for the paper and I pick whatever my engineering target and I make a solution for the user that is going to need. You're doing research here. You're not solving the problem of the user if you take everything from the article. But anyway, that's a different story. So that 5 kg, why they put 5 kg in the article?
5 kg here is actually stated in the article. It says that the average weight of the equipment they use.
The manual one.
Yes.
So again, you're doing the same as that one. So how do I know that one? It will do the user needs to decrease the strain and fatigue. If the manual now it gives the strain and fatigue to 8 kg, then you're using the same 5 kg, then you don't solve the user need. See, you have to think when you put numbers there. Right, when you put statement and number, then they have to match, they have to align. So that's my issues with your engineering targets. I think I mentioned it before, but I repeat it again. It's very simple, 3 of them, but you have to justify. If like 5 kg now for the current one, and that created the strain, then you have to go below that. And then not only go by your chance, by your choice, but you have to check from the health, from the standard, from whatever. Oh, when the weight is below this, then it doesn't give any strain. It's not your statement because you're not a doctor or you're not, I don't know, whatever in that field or safety guy, agent. So you have to have scientific, okay, similar for the first one. The last one, okay, you want to have for different ones, even though that one actually your validation is not correct. Here you're not going for a range. So if I have 4.1, then I met my design. No, no. Your target is to go at minimum 4, maximum 6. So you have to go to the 6. Because if my target is 6 and you should reach at only 4.5, then I cannot pass for the 3 when it is 6.
Okay. 4.5 is only the length of the pole.
Mhm.
But if we include this our height also, and pole, the pole, you know, the height will be increased.
Then in your things you should show that. You should do this, okay, you measure. Now this is 4. Because when we do 554, do I know, I mean, so the user has to have that height, the balance. If he's shorter, I cannot achieve. No, that's why you have to do validation. Even if you consider that, then you say, okay, average, whatever it is, or you take minimum the shortest guy, and then you have the things that you at least reach the 6. Alright. Otherwise, when you say 4.9, probably you won't reach the 6. Alright. Now, just one case of design analysis. I think also I have issues there, and then I stop it. Alright. So here, the first one, you use the 48 second. Assume that you should lose actually less than that, by the way. Yeah? But let's say 48. That gives you better production than the current one. So how do you use that one? Calculate what? In your system, which component you try to find here?
Actually, the system by the detailed calculation I did not put in the slide actually. But the 48 second, this is
No, because 48 seconds here you have the whole process.
the
Position, hydro cut 1, cut 2, position, I don't know. What are those?
Actually, we use the 15 second here because the 48 is the total from the cut 1, cut 2, and cut 3. So for the one cut is take around 30, but we put so it's very long that per second in 12 seconds, which is
Why you have 3 cuts? Can you? I don't understand.
usually when you cut the palm oil, isn't not easily when you cut the first one, your fruit will immediately
So you do 1,
one
and then
and
more.
then
What?
it doesn't work like
No, I mean you need a little more.
Yes.
And second, third, then it will fall.
yes.
So your time is 59 seconds. The cutting. Or you do by 15 seconds every cut.
The 12 second means that 12 pump means, and then the 12 stroke with times with the 3000 mm, which is 3000 is the oil volume, and then you get the 36,000. And for the 36,000 that we're going to use for find the piston area, which is 8. So basically we not use the 48 second but the 13. But in the calculation we use 12, not 13. It's 1 second slide.
So you're going to do faster
Yes.
by using 12 seconds. And this one I'm not clear for you, but anyway, this one you get what? The piston?
The diameter of the piston.
2.
Actually the slip piston to push the blade.
Okay. Assume fine, then you, let's say, and then the piston, so the diameter will give you the time basically. It varies if you have bigger diameter, smaller diameter, whatever, the influence with respect to the time, because you have stroke.
Because you use the time to find the diameter, like the 12 second, which is equal to complete 12 pumps. That's what I mean. So that's time, that seconds, it relates to the pumps, and then the pumps will times with the oil volume, and then the oil volume we're going to use for find the A. So that's the flow.
So the pump, when you buy the pump, one spec is like this, the stroke or whatever, 1 stroke per second or 2 stroke per second or whatever it is that the spec of a pump?
This spec is the
No, because how you chose that 1 stroke per second? Because you said assume, you said the pumping.
Yes, but I'm based on the research. Basically,
So your pump here, it has that one? You got a pump that it has one stroke per second?
I think maybe yes.
Maybe, okay. Anyway, so you found this one. The other thing, how did you design the blades?
The blade actually because there is no air because we just get the cutting area, the total surface area of the front of the pump oil, and then we can know that is it the length of the blade is suitable for the front or not. So I think there is no need to detailed calculation. We just need to know that how much the diameter of the front, and then we see the specification of the blade. Is it suitable to the?
You have the gun to cover the whole root, but also you have the angle, the sharpness, I think, on order to cut, otherwise. Because you cut like this palm through, not the same as cutting, I don't know, dry wood or metal or something. The cutter will be different for every kind of material in the sand. So I don't think like you can go just give me a cutter, no, don't give me anything, just the lamp. Dull, not dull, whatever, we'll see like how it will cut. I don't think so. Okay? I think you need to, for sure you need to do some calculation also for the blade. Anything else you have here? I think that's all right. Anyway, okay.
Can you?
So can you test the prototype, sorry? Can you test the prototype? I mean, you showed us the video, but I want to see if it is working.
But before that, a big disclaimer. In the video, we use water as working fluid, but right now we use this air because we didn't want to mess up this stage. So the force may be not really strong like in the video, but it is, I guarantee you, it will be working.
So take a look at the blade.
Yeah, I want to see the blade, okay? It looks very slow, the 1 stroke per second, but anyway. Okay, and because of the air that you said, I don't know. I'll give you credit on how exclude on that. Alright, and then the length, the thing, the other length.
Elongation. Only one people.
What is the total weight again?
1.9.
1.9.
You're supposed to demo with one people.
So exactly.
It shows that people need assistant to use your tool.
It's okay, they reduce the labor to use the machine, but they need the labor to help them.
To handle the machine.
Yeah. So this one is scaled down?
No.
So it goes to 6 meters.
Only the blade is scaled down,
Only the
right?
scale down.
So it goes to 6 meters? Are you sure? So how come this one then?
Show 6
Your
meters.
water don't go for 6 meters.
Oh.
Huh?
Wait, we will extend until the
They have
the
more
most long version.
Actually, it's a limitation with the tube. You just get this length of tube. If you get longer, so you can reach the middle.
Okay?
Give it a
No, but where is the liquid? The pump? This is the pump? Why is not attached to the pump? In the hand? This one.
See, because the tube is also not as long as the whole pole
No,
itself.
that's why I said that it worked. So, because you showed in the video it worked, why you have it not working here? I mean, or less short or whatever short, but then it was gone. You cut it after that or what? Anyway, okay. So make sure that it is, again, it matched. Whatever you showed in the video, the real one also will be the same. Okay. Alright, thank you.
Alright, question on the slide for the problem. I believe I suggest to all of you to justify the work of the inefficient during your previous presentation, if you notice, but still you did not declare or justify what is the inefficient. Okay, so inefficient in terms of which parameter?
Basically,
Yeah, I know the answer. Just now you answered to the parameter of the duration. Okay, but you didn't highlight. You can simply this is my suggestion. You can simply mention inefficient without the numbering inefficient in terms of what. So that is the point for the program identification. And also regarding your user your user the slide for next slide. Username and value proposition. So for the second username, likely to reduce strain and fatigue. So I didn't see the relation with the problem identification. So in your problem identification, you mentioned for the first one inefficient leading to delay collection. That's fine. This one is the username, and then the next problem identification is 3 high vulnerability. That one is referring to the username number 3. And how about the number 2? What is the problem? Is it mentioned in the problem identification?
it is still related with the first problem identification when we say with the time, like
That one related to reduce strain and fatigue. Is it regarding related to the time?
that's for sure because we need to bring the tools from a tree to another tree. But if the tool is not that like is a way, it will take time because we do the cutting, the harvesting is not just one tree. We do like maybe 50 tree, maybe 30 tree. You need to bring the tool, move from a tree to another tree.
Yeah,
So the weight must be.
Of the time, but the one that you mentioned just now to reduce strain and fatigue, the one is more to the health. But you didn't mention in the problem identification. So that is the start of the problem identification. So is there any proof or any research study that by using the current or existing design, it affect the health or the strain that you mentioned?
Since you declare it will reduce, lighter product will reduce the strain, so you need to do validation, right? Is it like only reducing the strain and fatigue? So I think better not to say about the after effects, the reducing the strain and fatigue. Okay?
Your design validation.
This one you can keep, but you have to justify that the 5 kg is related to that, because that's what you put as your engineering target. Is there a standard? Is there some health, whatever, OSHA, something that they say for worker to move something from whatever place, blah, blah, blah. If it is below 3 kg, they can work for 8 hours without fatigue. It's like what we do for acoustic. You can go below 80 decibels. It should be maximum 80 decibels for 8 hours. Otherwise, you will lose your hearing and safety, blah, blah, blah. That's a standard for everything. So if that is a standard for that, and it is 5 kg, then that's your justification. But if just for, because if it takes something heavy and light, that's not your judgment. For me, okay, maybe 5 for me doesn't make me tired, but for him it makes me tired. So we have to have a standard for everyone. Okay, you understand? Otherwise, like I said, the other complicated one is you measure this. You have some sensor, whatever, to see the strain, the fatigue, and whatever. I don't know how they measure what's the units. And then you have to do the test. When you do that, you put that and you measure. Does it reach that level of strain or fatigue, or it's below the target that I put? Blah, blah, blah. It has to be scientific. It cannot be just, kind of think, this will be kind of use, it's better. Logically, yes, but we want to see number.
Yeah, that's number 2. And number 3 is regarding your design specification table, your target, your engineering target, which is still in username number 2, which is to minimize, number 3, to ensure that it will reach average height of all blah 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 of 4 to 6 meters. So where do you get this value? Is there any reference or any?
There's a reference that state that the average from all three here is
From which reference? How do you identify that what is you consider your
The
benchmark?
user,
4 to 6 meters.
uh,
Or just state the value?
Standards,
Yes.
manual,
from the article, but
Which articles?
I don't remember that. It is always stated in the report, calculate as the and then you can see that it is stated that 46 is the height of the
Trees in
FFB,
Malaysia.
the FFB, the fruit, not the highest tree because the fruit is not at the top of the tree. So 46 is the height.
the shortest tree or shortest fruit is 4, the highest within Malaysia is 6. Right.
Yes.
Okay. Right. Last point is design analysis number 3. Okay. How do you decide workload 2000 and also the workload 2000? How do you decide? Can you justify? How do you make the assumption?
This is also from the article that we do some research.
You guys, you have to link this to the engineering target. This one is engineering target linked to the 4 to 6 meter, right?
Yes.
Yeah. So why you need all this calculation? I'm really intrigued.
So
That's why I said your design analysis is not proper, but this one is even worse case. I mean, why you need calculation here too, while your target is just 4 to 6 meters? So just make sure that your things, this is the shortest, the lowest setting of my thing, 4. The longest is 6 down actually. You don't need to do much calculating.
but if we do only one straightforward to 6 meter, it will be more safety factor. It will break the pole or vibration and so on. We don't want that. So that's why we calculate to find the segment. So the workload fee 2000 newton is divided to each segment.
Yeah, but what do you mean by workload? Is it the weight?
The weight and the cutting force in total.
Weight of what?
Cut the 3 odd.
No. And the weight is, you're not carrying the weight with your machine, you're just cutting it.
So if with the current tool, the 2000 is the when you cut the tree.
Yes. So that one, not for your case. That one for he needs, because you, that's for the cutting, that's for the blade design. You know, because currently how he cuts, he has the blade, right? So to that force that he give you from the pump and all those things, so then your scissor will do it. Here he has to give that force to cut. Definitely he is whatever, that 200 which is the human maybe you take. For your case, that one is not relevant. But if it is relevant, that's why you put it like a design number to actually design your blades. Right? So then it will give the same force to cut your blade when you give the pump and stuff. That's why I said you need to design your blades. That has nothing to do here with the length. If you want, like I said, to take for safety, not to vibrate, then you have a different design. You have to add other engineering targets, that the frequency should be less than this, then I don't know what, the weight should not buckle, should not bend, different design. Here you said your target is just the length. Minimum 4, maximum 6. So just make sure that you have that one, that's it.
And how do you need it? You need to stop.
Yeah, okay. Alright?
Last question.
Yeah.
How do you relate the number segment with the range that you give 4 to 6 meters? How do you prove the number of segments can justify with the length?
You can see the calculation that the number of segments, secondly by the elemental, divided by NC, this is to get path here, because you know that the V we have the segment, if we reduce the load and we divide the load into each of the segment. So the calculation we identify, meaning the first segment is the essential one to keep the section short now. So that's how.
Yeah, but that one based on this force calculation, right? But actually not need force calculation for you.
Yeah, the first.
The other force is coming from here, you know, like when I put this, then I have to pull. So that's the force he needs to come. You don't have it. I mean, you have it, but it's not affecting you. Yeah, but it's not affecting your things. You're not applying on the structure. There, when you apply the force, these guys will do it from the pump. The pump will do this, and then it will do it. So the human, I'm not applying any force. That's why it's not related to the calculation. Okay? Yeah, otherwise we're going to stay after Isha, I think. Let's group. Already two groups?
Yeah, thank you.